Okay, so hello everyone, this is Rishikesh and welcome you all in this live stream. So today we are going to discuss some of the liquid problems. So let's get started without wasting any of the time. So let's get. So I'll pick one question from segment tree. Okay, then I'll try to solve that, and one question from sliding window. Okay, so I'm going to pick two problems. One is from sliding windows, and second is from segment tree. Okay, so go to chat gpt. Okay, then it will suggest me actually actually let me discuss something. So sliding window problems are really good problems, and this come under the hard category of lead code. So and any in general, this is the one of the toughest topic that most of the student ignores while preparing and while solving problem, and even though they are not even able to solve it in the interviews, but so that is hard actually. So if you are not able to understand in one go, then try to watch it multiple times, then you get. Okay, let's start to. Okay, so I'll ask here to give me some segmentary problems. Okay, segmentary problems of lead code. Then I'll get some problem. Then I'll try to solve them. Segmentary problem are good ones. So actually, this is longest increasing subsequence to. Okay, this seems to be new, but is this from segmentary? I don't know. I don't know what to do. Actually, I don't think it is from segmentary because you know what? This is dynamic programming. Let's see. Oh, I got. Due to my mobile, I am getting some deep latency. So yeah, you are given an integer unknowns and an integer k. Good. Find the longest subsequence of norms that meets the following requirement. Okay, it should be strictly increasing. That is good. The difference between adjacent elements in the sequence is at most k. Not an issue. Not an issue. Return the length of the longest increase that meets the requirement. Okay. A subsequence is array that can derive from the array by deleting some more elements without changing. Okay. So actually, we have to find the longest increasing subsequence. Okay. And I think okay, understood. So actually, actually, 2 or 3 weeks ago, I tried to solve this problem using dynamic programming, but due to the constraint on the size, I was not able to solve that. But okay, see this, what is the acceptance rate? 26%. That is too less. That makes this problem too hard. Okay, so the main issue in this problem is that this size. With this size, we can't even use the dynamic programming. So in the dynamic programming, we need n square complexity, then only we can solve that problem, right? So as of now, I'm going to delete this problem. I'll gonna solve in next live stream, or maybe I can solve today, but we'll discuss later on. But the main agenda is that this is the new concept. We will use lazy propagation kind of concept. So as of now, I don't have idea like how to solve this. Honestly speaking, I don't have idea. Binary index tree, segment tree, monotonic. Okay. So as of now, I don't have idea what to do. That is good. And second thing is that I need to revise some of the segmentary, then only I can solve that. So for now, I'm going to choose sliding window good problem. Okay, then I'll try to solve that. Actually, sliding window problems are also very good. So you can't even understand the sliding window problem. So we have to consider that as well. For this problem, for the sliding window problem, I will refer from Striver to just sheet because I just wanted to revise the concept that is good to know, not only continue with. And lately, what we can do is that firstly, try to solve a sliding window problem because yeah, it's been 10 to 15 minutes and I don't even start solving the problem. Not an issue. We'll continue. Sliding window, stack queue, bit manipulation, recursion, linked list, heap sliding. Okay, sliding window. Sliding window, hard problems. We'll pick up some hard. Minimum windows of string. I don't know how to solve this, but I don't even seen this. Maybe I solved the. Okay, I have been solved. Okay, so here, mm, given two strings s and t, that is fine. Of length m and what the hell is? Oh my god! I'll pick another one. This is too complex to handle. Minimum window subsequence. If that works, then we'll add. Yeah, that is premium. Mhm. I can also solve this, not a big issue. I can also solve this. So sliding window are pretty easy, pretty easy. Novel of substrings containing all three characters. Easy, easy. Not going to solve the sliding window. Try to jump onto the greedy algorithm. Some medium question and so try to do firstly with easy. Assign cookies. Okay, okay. So yeah, let's do it. Assign cookies, so we need to assign the cookies. Uh, this is easy one. Assume you are so this is even though easy one due to their constraint, but we'll try to optimize it as well as much as we can do. So assume you are an awesome parent and want to give your children some cookies, but you should give each child at most one cookies. Okay, not an answer. We'll give one child for cookies. So each child I has a great factor gi, which is the minimum size of a cookies that the child will be content with. Okay, not an issue. And each cookie j has a size of sj. If sj is equal to greater than gj, we can assign the cookie j to the child I, and the child I will be consent. Content. I don't know what it is. Okay, so actually I don't know what is this meaning, but let's do some Google search. Google Translator. Student. Okay. So this is wrongly written, but not an issue. Will feel. So what is the or what just Santosh? Content means Santosh. What the hell it is? Okay. Content samagri. And I will continue my summit. Okay, not an issue. So content is simply meaning that satisfied. Okay, means that child satisfied if they are getting more cookies than is satisfied. Not an issue. Move ahead. So assume you are awesome. Okay. A child okay. Or so okay. A child I has a great factor GI, which is minimum size of the cookies that a child will be content with. Means they are happy if they are getting more than or just GI. Means that we need to give the GI or more than GI cookie size. Otherwise, it will children will not content with that. Okay, and each cookie J has the size S J. Okay, if the S J is greater than J, will assign the cookies to J. Okay, and the child I will be content. Your goal is to maximize the number of content children and output the maximum number. Okay, you have three children. Okay, so and two cookies that are nice. The greed factor of three children's, and even though you have two cookies, since their size is both one, you could only make the child whose greed factor is one. Okay, not an issue, not an issue. Simplest problem that I ever seen. So I have grade one, grade two. Then this is also not a big deal at all. I don't think this is that much of hard, but I can solve this. Okay, try to get minimum with minimum. So basically, it is too much simple to do that. Arrays dot sort. Okay, firstly I'll apply arrays dot sort. Then I'll provide G. Okay, then again I am going to sort S. Okay? So both the arrays are now sorted. That is the good thing. So maybe I take from SSC. Mhm. Okay. So the main motive is that we have arrays dot sort G and we have arrays dot sort S. Now, okay, good. Then mm, both are sorted. So we are taking two pointers. Okay, let's see what I am doing that. While I have about okay, so actually I have two pointers and I is equal to 0 and then j is equal to 0 as well. Okay, and while nm, okay, we'll take n and m. N is equal to g dot length and m is equals to s dot length. Okay, so actually loop will break. We'll also need to do a counter. Okay, counter that in the counter we are going to store the answer. So what is the idea? Firstly, I'm going to explain the idea. Try to even though be careful so that it is the main portion of video. So what I am going to do is that I am going to sort both the arrays firstly, like this sorted in here. And I am going to pick two pointers. One is pointing onto the G and second one is pointing onto the X. S. So if and I am going to compare these pointers values. Uh, if S is greater than or G, this simply meaning that we can give uh, this cookies S to the children this one, because that children only need one and we have already one, so we can provide that. Okay, so there is not an issue, we'll do that. If the children is happy with the cookies, then we can just then they can get. Okay. And we improve the both the pointers I and j as well. So I is going to point to this one and j is going to point to this one. Why? Because these children taken this cookie. Okay, so we can't give this cookies to another children. So here this is done. Now we again come to this point. I is pointing to 2 and j is pointing to also 2. So again we do the same approach. Let's suppose this is 2. Let's suppose a scenario in which I is pointing to 2 and j is pointing to 1. Okay, so in this case what we have to do that we clearly see that the children needs two size cookies and we have one size cookies, so children will not happy with that. So we need to increase the size. And and if this children is not getting these cookies, it simply means that the other childrens that are mm, just front of this children, they can't even they can also not get this. Okay, they can also not get this because we have already sorted G. So we have already sorted G's, meaning that the next number is that next number must be more than 2. So let's suppose this is 3, 4 or 5 or something else. So if it is 5, then we can clearly set this will never going to happen. So we have to not increase this pointer, we have to increase this pointer so we can somehow make this child happy to get their cookies. Okay, so in this manner, if the size is more than the size of the cookies and the student expecting that, so we need to move forward the this j pointer. So j is now pointing to here and I is pointing so here. So now the both the children are happy, then both no sorry, so student get their cookies, so we can increase this pointer, right? And the most important thing about this problem is that, so we have also third condition is this. So if this is 2 and this is more than, okay, this is 2 and this is more than, not an issue, not an issue. This is 2, this is more than 2, that simply means that children is happy with this, so we need to increase. And the if there is 3, then if a smaller number is here, then we can simply say that one is absolutely included already, so we know we do not need to do anything, we are happy with that. So firstly I will kill less than m and j is less than n okay. So I is less than m, j is less than m, then only run the loop. So actually if any one of the get filled, then a loop will break. Simple meaning that. So if if g of I is less than equals to, okay, so g of I is less than equals to h of s of s of j, then in this way we can increase the pointer and then increase the counter as well. Else what we can do, that increases pointer, so we'll get some another answer. And in simple way we can return count. This is the one of the simplest thing that we can do to get the answer. Nothing need to do that. Literally nothing needed to do that. Quite simple problem. Yeah, everything is finished in just one click. So don't worry about anything. Try to solve that problem. Practice makes you perfect. Otherwise, there will be not any chance to get that. Now moving valid parenthesis. This is the good question. Yeah, we can do this. It seems something new. Let's see that how we can do that. This is I'm not gonna solve any easy problems. Let's pick up some good one. I already solved jump game. Not an issue. Actually, how can I solve jump game using greedy solution? Is this possible to solve? Jump game using greedy solution. I don't think we can solve it by greedy problem. Is it possible to solve by greedy? Ah, mm, let's become some problems that I am forgetting. Then only I will able to revise that. Mm, mm, mm. So, I want to solve try problem. Try are literally hard ones. I have solved that. Try problems are literally hard problems. So we can solve try problem as of now. We'll later on see that. Hmm. Okay, I'm not gonna take more. So I'm going to give a contest. Finally, going to give, and then in the contest I'll getting uh, three or four. Actually, I'll try to solve firstly third problem, so then I'll move into the second one. There is only option to do that. Otherwise you can do that. Okay, let's get started. Mm, oh my gosh. Oh my god. In simple way. So I'll gonna pick up a contest. That can be anything, problem anywhere. And and try to solve firstly third problem, then move to second problem, then move to first problem. Okay. And if I'll get some time, then I'll try to solve fourth as well. Okay. Let's get that teacher. Let's attend it as a virtually. Live or not, let me check because I'm trying to tell a lot of things. If I'll not try, then it will be problem for me. I am live. I am live. So from 2 or 3 days, I am regularly coming live. Not an issue. Good thing. Good thing. Good thing. Doing some better thing on the daily. But what is opening that? Okay. Oh, first one is medium. Already solved. But not solved the second method. Considerably some unnatural unsatisfied with the 5 days of I have solved that, but is it solved? What the hell is? Let's do third one. Okay. Also solved. Okay, okay, okay. This was a good one. Hmm. So you are given an integer n representing the number of nodes in a directed weighted graph, numbered from 0 to n minus 1. Correct? Directed weighted graph. So listen that carefully. Directed weighted graph. Okay. You are given an integer n representing the number of nodes in the directed weighted graph, number from 0 to n minus 1. Correct. This is represented by a 2D integer array ages. Good. Where ages I is equal to ui vi weight I represents the directed graph vi and notes you are also given a string levels of length n where levels I is the character assigned to the node I and an integer k, the minimum total age weight of a path from node to 0 to n minus 1 such that the concatenated of the labels of the node along with the part contains at most k consecutive identical characters if no valid path are returned. This question is one of the beautiful problem that I ever seen and tried to figure it out the approach where this question will break. Now, what we can do is that we have given something, this string labels I. Okay? Where is where is that string actually? Huh? Yeah, actually we have given levels. So this is AAP. So actually, labels I. Mm, the length. So the character assigned to node I. So on node 0, we are A. Node first, we have A. On node second, we have B. Not an issue. Whatever we have, just accept it. And K is equal to 1 means that we can only repeat one times. We can't repeat A like that. Just need to okay, one time. I hope this is clear. So the optimal or valid path from node 0 to node 2 is as follow. Use okay. So actually, yeah, let's take this problem. This is one of the beautiful problem. If you can solve this, very good, very good for you that you could solve. But let's figure out the approach. Firstly, I am going to tell you something that the complexity and the constant is 10 raised to power 4. So we have the n is equal to 10 raised to 4. Be clear with that. Okay. Now open Excel. Actually, Excel want me that your storage is full, so you can't do anything. Okay. What the hell is? I'm gonna delete something. It's too much. Already huge storage is filled. When are you going to get that? Just delete everything. Delete whatever I can delete. So not an issue. We'll delete little of my issue. So basically, the problem not firstly pets that. Okay. So here we have a zero. Mm. So here we have zero. Okay. From 0 to 1, we have one node. From 1 to 2, we have second node. From 0 to 2, we have a direct node. Yeah, direct weighted graph. Okay. So here there is A, and B. So K is equals to 1 means we can only repeat to 1. Okay. So so we can't repeat that much. Understood? And the second, so actually what we can do is that we have one. So we'll pass this character as well. A. This is called the previous one. Okay. So this is the one of the simplest problem that I am discussing. You can easily understand. So firstly, let's see. We have this is the graph. Okay. So let me bold something. So this is the graph from 0 to 1. We have edge, and on the node 0 we have a character A. On the node 1 we have character A. On the node 2 we have character B. So the problem is saying that we so so the problem is saying that in the valid path, in order to find the valid path, we do not need any path that have consecutive characters more than k times. I hope you understood. So we need to track that how much characters are repeating, means that from 0 to going 1. So we need to somehow calculate that previous on the previous node I have character A, on this node I have character B. When I am going next onto the node 2, then we need to track that this is the different character. So we can like think that okay, yeah, we are So we need to simply know that uh, our characters are repeating, then we can make a variable r, that means repeating. So we can, firstly this is 0, okay, this is 1, okay, firstly this is 1, and then in the we'll create a node, okay, so we'll create a node. So why node? So in this node we are going to we'll use a queue data structures. So in this queue data structures we need to put some of the values to like traverse from this for the traversal. So to store the nodes in the queue data structures, we need a no, we need a node because we need to store some additional information as well along with the along with the node index, you can say. So firstly we'll node index. So index, let's suppose this is I to 0, and then we'll also uh, somehow we also need to somehow we also need to track about repetition. So I'll make a repeat character is equal to 1 because the repeating is 1 only, okay, from, okay, and the cost is, the cost is this cost, okay. The cost is as of now this is 0 cost. So and so when I pop this node from queue, then to traverse the neighbor nodes, so what I'll do, let's say this is the important thing. So when I pop this node, this is a node I is equal to 0, this is the node. So I'll check that which one are the who is the neighbor of this node. So finding the neighbor of this node, we actually mm, we actually use the adjacency list to traverse the neighbor nodes. So we'll get 1, we'll get 2. So this it has two neighbor nodes, 1 and 2. So for one for one see this carefully, this is the most critical part that we'll gonna understand. This is the most critical part. For one, for node 1 we have I is equal to 0, right? So in, so we have mm, okay. So for 1 we see that what is the character of this parent. So this will say the parent has character A. So we're gonna check what is the character of this node. So it will say the character of 1 is also A, means that parent character is equal to the child character. Okay, this is simply saying that the parent character is equal to the child character. In this way, so A is equal to A, then we can say that the repetition is happened. The parent uh, letter is equal to the child letter. So we have to increase the repetition. So on that node, the R is equal to 1. So we'll need to increase the R. So R will become 2. R, we need to store the R is increased by 1, and we'll check is it is less than or equal to K. If it is not less than or equal to K, then it will not gonna further add this in a queue. Why it is not gonna add this in the queue? Because it violates the condition. here clearly mentioned that consecutive identical at most k. So it is, if it is exceeding the value of k, then we'll not gonna pursue with this. mm, we'll not gonna pursue with this path. We can't take this path because in this path the repetition is more than k, so we'll discard this path in simple way. And if it is less than or equal to k, then what we can do is that we can add into the q dot add. It is quite simple. Q dot add, in the q we're going to add, what we're going to add, okay. So in the queue we'll make a new node, and index will be I, index will be j, or j. This is the this is the ah, okay. Hmm, Index will be j. Path will be the path from C plus the cost of the cost whatever you are getting here. Okay, the cost. And then a repetition happens, so we'll increase the value of r will be increased, so r will be getting 2 over here. So in simple way we'll get r plus 1. Okay, then we'll put this one and we'll put this one, the second child. And then we are finding the shortest part, so we'll not going to use only q here, we'll try to use priority queue. Why priority queue? Priority queue because we'll try to find out the minimum path weight. So we are like need to reach as minimum as possible while preserving this condition. So we do not need to violate this condition, and just no need to violate this condition, and just need to reach the path as soon as possible. That is uh, enough. Enough. Okay. Okay. Got it. Got it. Got it. Everyone. Okay. I hope you guys are understand. Let me code. Let me code. Let me check from like how much times I'm live, because it also matters a lot, because
Got it, got it, got it, everyone.
it's already 42.
Okay.
It's already 42 minutes.
I hope you guys are
Not an
understand.
issue.
Let me code.
This is
Let
the
me code.
build.
Let me
This
check
is the
from like how much times I'm live because it also
yeah.
matters a lot because
So
got it, got it, got it, everyone. It's already
okay.
42. Okay,
You know
it's
what?
already
This is not
42 minutes.
too much
I hope you
important.
guys
The people
are
who know,
understand. Let me code.
they will
Let me code.
sweating about this.
Let me check
Okay.
from like how much times I'm live because it also matters a lot because
So
got it, everyone. It's already 42.
you know
Okay, it's
what?
already
This is not
42 minutes.
too much
I hope you guys
important. The
are
people who
understand.
know,
Let me code.
they will
Let me code.
sweating about this.
Let me check from like how much times I'm live because it also matters a lot because got it, everyone. It's already 42. Okay,
You know
it's
what?
already
This is not
42 minutes.
too much
I hope you guys are understand. Let me code. Let me code.
about this.
Let me check from like how much times I'm live because it also matters a lot.
Plus node and
So, everyone is already 42. It's already 42. So much I have to let me forward. From like how much time I'm alive because it also matters a lot.
int I into
And
r
so, everyone is already 42.
this that
It's already 42. So much I have to let me forward.
and A easy peasy. Thumbs up. Okay. Easy peasy. Thumbs up. Okay.